Hey folks, have a quick homework example for you. This is covering factoring trinomials. What I want you to notice about this problem is the leading coefficient is equal to 1. Now, what do I mean by the leading coefficient? Notice what we have going on here. We have a variable squared, and then the two variables that show up multiplied together, not to a power, really to the first power, and then variable squared in the back. And so if your first term is squared, your variable squared, and your last term variable is squared, that's considered descending powers order with the u's coming first. This could be rewritten as 60t squared minus 17ut plus u squared, but that would make it one of the problems where the leading coefficient is not equal to 1, which is more trouble. But what I'm trying to point out to you is, in this particular case, notice the leading coefficient is 1. And when you have a trinomial like that, with the first term squared, and then the next term to the first power, and the last term is either a constant, in other words, just plus 60, or it's got another variable squared. This is in the right order. And what you do to do these is you find two numbers that multiply to equal 60, and at the same time add to equal negative 17. Now, if this problem factors, if this trinomial factors, there will only be one pair of numbers that makes this true. If there are no pair of numbers that makes this true, then the polynomial is prime. So what do I do to do this? Well, what I want to do is take a look at all the factors of 60. A product of two numbers that multiplies to give me 60, and then we'll check to see if they add to 17. Notice they have to add to negative 17. How am I going to do that? Well, every single time your last term or your multiply term is positive, yet your middle term is negative, this implies that both the numbers are negative. Okay? On the other hand, if the last term was positive and the middle was positive, both numbers would be positive. Now, it's a different story if this is negative, okay? Anytime the last term is a negative value, in other words, your multiply value is a negative value, one of your terms is positive and one's negative, but that's not what we have here, so we know both are negative. Now I start thinking about things that multiply to give me 60, like 1 times 60. But y'all, if those are both negative and we add them together, that gives us negative 61. So that's not it. Try 2 times 30. Okay, again, if you check negative 2 plus a negative 30, that adds to be negative 32. That's not negative 17. Just like above, adds to be negative 61. Again, not it, not it. What about 3? Does 3 go into 60? Yeah, sure does, right? So 3 times 20, but when I add the negative versions of those together, I get negative 23. Not it. Okay, does 4 go into 60? Yep. So you've got 4 and 15, right? 4 times 15 is 60, but negative 4 plus a negative 15 adds to be negative 19. Once again, that's not our result. Does 5 go into 60? Sure does, right? 5 times how many? 12, right, is 60. If I add the negative versions of those together, I get negative 17. Ding, ding, ding. That's our winner, right? So my two numbers are negative 5 and negative 12. What do I do with those two numbers? Well, first of all, this problem factored is like this. So you're going to have a binomial, two terms here and two terms here. What goes in the first position whenever your leading coefficient is 1 is the square root of that first variable. So u goes here, u goes here. What goes in the second position are those two numbers that we just found, negative 5 and negative 12. But this has an extra issue of this t squared and this t term here. The way you fix that is you put that t value with the two numbers that you found. Now, I don't want you to do these problems without checking them. So u times u is u squared. I'm just using the FOIL method to check this. U times negative 12t is negative 12ut. Negative 5t times u is negative 5ut. And then negative 5t times negative 12t would be plus 60t squared. Question is that the same as what we started with? Well, yeah. When you add those together, you do get u squared minus 17ut plus 60t squared. Therefore, we know that the green up here is factored correctly. I hope this helps.